apparent when this particular outcrop was brand new. The road was widened and deepened in this area near. And for years, there were no fossils to be found on this outcrop, even though it was down the lower part of Lexington limestone. And kept looking again and again. The mineral collectors would find fluorite veins on this particular outcrop, and it was really nice for those things. But finally, the outcrop started weathering, and I started finding lots and lots of crinoids. I even led Dave Meyer and a bunch of other dry dredgers, as well as KPS people, to a field trip one time where we crawled over the surface where the Brachiospongias were eventually found. And not realizing the Brachiospongias were there. We found all sorts of spectacular crinoids and other fossils, but no Brachiospongias at that time. Sort of getting back to the slides, like I should have done. These rocks basically formed at a time period when North America was very close to the equator, the paleo equator with North America. And there was a lot of sedimentation of lime mud in this particular part of the world. Just like we have here in the Cincinnati area, the rocks were basically formed from lime mud, ending up with limestone and shales. Lots and lots of storm deposits, and a few pieces of evidence for the early formation of the Appalachian Basin, the Appalachian Mountains. Basically a part of the formation of the Appalachians known as the tectonic orogeny. In central Kentucky, you can find various volcanic ash beds, and even flow rolls that are thought to have been formed by ancient earthquakes associated with some of the early stages of the formation of the Appalachians. Here's a more detailed thing showing a little bit more of the paleogeography, showing that the central Kentucky, southern Ohio area was fairly shallow carbonate formation, lots and lots of coarse-grained limestones, lots of storms. Off to the east, you have a lot of the more terrestrial sedimentation forming, with the very, very start of the Appalachian Mountains eroding and depositing clays and sedimentary plastic sequences to the east. There's even thought to be a volcano located down in the very tip of the southern tip of the Appalachians that formed a lot of the different volcanic ash beds that are associated with Middle Ordovician rocks in Kentucky. Here's just some pictures in space showing deposition of limestone, how it is occurring in the Bahamas today. Central Kentucky was probably very, very similar to this as it was Ohio. You get lots and lots of clear water carbonates, very milky look to some of the water where the carbonate mud is being formed both chemically and biochemically. So here's a geologic map of Kentucky. Ignore the location with the arrow, that's from another talk. But anyway, central Kentucky here is all Ordovician rocks. And if you get down to south central Kentucky, you actually get areas along what's known as the Palisades of the Kentucky River, where lower Ordovician carbonates, or not lower, but middle Ordovician carbonates are exposed. Stuff that's much lower in this section than you have here in Cincinnati. Here's the outcrop where I found the Brachiospongias for the first time. And it's got a really nice sequence of carbonates all the way from a unit called the stone, which is basically a tidal flat unit, has mud cracks, very, very fine-grained limestone, and ends up being formed in very, very shallow water that was tidally influenced. If you have good exposure, you see lots and lots of mud cracks from when the particular rocks, when the sediments dried out at low tide. Sequence grades up into several layers of volcanic ash, called bentonites. And then the very lowest part of what's called Lexington limestone is a carbonate unit that's characterized by coarse and fine-grained sedimentation. Lots and lots of storm beds. Some of the different rocks will be coarse-grained and fine upwards from layer to layer. Anyway, this is the outcrop where most of the Brachiospongias came from. And it grades up into another member of the Lexington limestone called rubbly, and has a lot more evidence of bioturbation from things like clams and stuff like that. The unit that actually found the Brachiospongias in has lots and lots of hard grounds. And I'll get into all that in a second. This mine?
Oh, I guess it was.
Need it. Anyway, here's a somewhat antiquated geologic column. All of these rocks are now referred to as upper Ordovician. The actual numerical ages of these, the absolute ages, have not changed, but there has been a change in the classification of the rocks. based on these particular volcanic ashes and date the rocks. And they consistently come out to about 454 million years old. So that gives us a date of the very base limestone. Additionally, there's numerous additional bentonites in the lower parts of the... Many of the shale layers have a very popcorn, very well on like oil well logs, radioactivity logs. These things can be traced for long distances. It is characterized by these features known as hard grounds. And hard grounds are places where there's evidence that the rock actually lithified back in the Ordovician, whereas you would normally think of most of the sediment being soft sediment. It actually lithified back in the Ordovician and got bored into by various sea creatures. It got eroded, and in some cases it actually got encrusted. There's some beautiful crinoid holdfast in some of these outcrops down there. And you can see there's a really nice crinoid holdfast here. If you look in detail, you can probably see other holdfast as well as evidence of erosion and boring. There's a lot of relief on individual beds. It's almost like walking along a rocky coastline today is what you would see at this particular outcrop if you could go back in time. Here's another crinoid holdfast, a very large crinoid. And you see lots of evidence of boring into these particular pieces of limestone. There's an abundant echinoderm fauna associated with this. And that's what I first started looking for when I found this outcrop was starting to weather. Every trip, I would find just fantastic crinoids. Usually just one or two every trip, and it's like 40 miles from where I live, so every Saturday for years, and I didn't have another field trip to go to, I'd go down and I'd collect one crinoid. Every time you think you'd clean out the outcrop, wouldn't see anything else there. You'd let it rain, you'd go back, and there'd be another fantastic crinoid. In some cases, you found edrioasteroids, like this one here, sitting on hard grounds. This one isn't encrusting a brachiopod like most edrials do. This is Forcerista discus, isn't it? Is that how you say it?
Forsty discus.
Forsty discus, yes. Anyway, this one's sitting on a hard ground. And there's two more on this particular slab. I have one big slab at home that has about 15 edrioasteroids. My friend Rick Schrantz has found one that has 6 arms instead of 5. They're really, really abundant at this particular, well, they were really abundant. We pretty much cleaned the outcrops out. I've invited people to collect with me before now. They'll bring all these boxes and things. I'll tell them, bring a 35 millimeter film canister and a little tiny cardboard box. That's probably all you're going to find on one trip. By the time Dave went with us, we found paracrinoids. I think you found a Carabocratus. And it was just easy crawling around on this one shale surface, finding really beautifully preserved crinoids, as well as occasional edrials and paracrinoids. Very diverse marine fauna. Here's a very large crinoid stem. This is from a species called Calicocrinus. And this is one of these really, really large primitive camarates. And it took us for a long time to identify what it was. But anyway, this is of considerable length, and it has a bryozoan colony growing on it. I apologize, it's a little bit dark on the slide. Additionally, most of the sediment is just loaded with pilnatozoan debris, not only crinoids. We found fragments of edrioblastoids, all sorts of other really bizarre echinoderm fragments. You can find a lot of the different ones depicted in this. Unfortunately, Carlton showed up, and I think I stole some of his artwork. You can find paracrinoids and various crinoids, trilobites, unusual types, not only Isotelus, but some of them were Ceraris, and some of them were unusual types. This stuff is very, very much like the Bob Cajun formation that's found in the middle Ordovician of Canada, Ontario, Canada. So you find many of the same types of fossils. Somebody try to focus that a little bit. Occasionally you find Hybocrinus or Hybocrinites calyxes. There's another outcrop down at Clay's Ferry where I found this particular crinoid. But in recent years we've even found several specimens of the edrioasteroid very similar to Edrioaster bigsbii that's famous from Ontario, Canada. And some of these things are half-dollar size. They're very, very large edrioasteroids. But after years of walking over this particular outcrop, Same shale beds, picking up the crinoids, looking at the hard grounds, all this other crap again and again. One day I started noticing there were these unusual fossils. And I finally realized that they were fragments of Brachiospongia. And after all these years of looking, it was just amazing.